So my name is Langley. I'm the Director of Digital Delivery at Bryden, and I lead our Creative Technologies team. And this morning I want to take you through a little bit of the background of the team, what we do, and show you some examples of the kind of work we've produced. So for those of you that don't know Bryden, we are an integrated architecture and engineering company. We've been around for about 20 years, and these are some of the things that we do across the construction sector and the design sector. So we started as an architecture company, but actually we grew a series of other capabilities. We have a background in design for manufacture, and wherever we couldn't find engineering or other partners to deliver design for manufacture prefabricated solutions, we basically built that capability in-house. And one of those capabilities is around digital technology. So Creative Technologies is a team we established only a year and a half ago within Bryden. So it's a bit different to the usual appearance, let's say, of tech within an engineering company. We're specifically a computational design team. And we do not typically provide computational design support services to our existing architectural engineering projects. We exist as a computational design team, creating digital tech for our clients, directly for our clients. And these are all the people in our team, and these are all the topics that we explore. So we're interested in these 6 topics: algorithmic design and simulation, modeling and analytics, robotics, geospatial, web technologies, obviously, as well as XR and interactions. That's virtual reality, augmented reality. And for us, all of those things are interconnected. It's not about horizontally stranding any of those topics. We try and leverage one against the other and build our technology in a way that any client can access any of those threads themselves. So the size of the team, there's 23 people. You saw all their names just before. 23 people in creative tech. In Bryden as a whole, there's 200-ish. So we're a little bit more than 10%, which is a pretty good number, and it gives us a good scale in order to really have an impact, actually. And that's the breakdown between the disciplines. So we're actually quite evenly broken down across the company as well, between architecture and engineering, and then the place of digital within that. And 96% of my team, we are architects and engineers by background who have then specialized in computational design. So although we are a computational design team building software, we are not a software development team specifically. And half of our team are women. The build-up of this team is super important for me. We had the opportunity to build this team from scratch. Technology is not really just about technology and hardware and software. It's certainly about the people and the culture that you can create when you implement a whole new way of working. Yeah, and I can't really stress this enough. We are not a software development team. We are architects and engineers who build software. And that's a very different thing for us, a very different kind of activity. I've been an architect for 15 years. Most of that, I've been designing buildings. When you design a building, the thing that you give to a client, the product, is the building, and they get to use it, et cetera, et cetera, et cetera. When you make software, it's a very different process for us. When it's not transactional, it's a very reflexive process. We work with our clients directly to find out what it is they really need. We don't make software and then approach them to sell it to them. We actually build it for them, and that process is something that we provide for them as a service, as well as the kind of software outcome. So that's just a range of some of the apps we've built over the last 18 months for various different clients. And one of the topics that we really do focus on as a benefit for clients is automating design. There's a big topic in the industry. It's a big topic for architects and engineers, but it's also a big topic for clients who are paying fees to architects and engineers who are designing buildings for them. So automation is coming to the sector. The clients obviously want to see reduced fees, but also other things. So for us, automated design means not just doing it faster, it means doing it smarter. It's no good just repeating the same process, but sticking it through an algorithm to make it a bit quicker. This is an opportunity to do things in a completely different way. So let's do it smarter as well. And doing it smarter means you can pass that intelligence directly onto a client. It's not transactional. This is not about building things that help an architect do their job better. It's about changing the kind of technology that's used in order to design and develop buildings. And in order to do that, we have this kind of approach to build a data lake of everything that can be of interest to a client, to deal with their problems and to find solutions for that client. And that allows us to leverage any of those approaches, whether it's mathematical modeling, IoT, robotics, geospatial, whatever that is. We build it all around our data lake. And this is how we do it. So we typically use geospatial data as a baseline. So everything is in the real world is geospatial, so everything in the virtual world should also be. That's not normally true in design software. And secondly, we're interested in client business data. This is about embedding the USP of our clients into these processes to enable them to leverage and realize the value in the process. And finally, let's go back one. And finally, the specific data that we might generate ourselves on their behalf from their project. So these 3 layers go into the kind of automation apps that we're interested in building. I'm going to take you through 3 examples, the last one of which is a bit spooky, but it's an interesting one. The first 2 are a bit more accessible, I would say. So this is an open source web app that we just released, I think, 6 weeks ago. It's an Innovate UK funded project for a web app to design primary schools. So primary schools are controlled by Department for Education brief. There's a very strict brief around space standards, around how you can actually design a school. These rules are kind of set. Once you have a lot of rules, we can do a lot of configuration. So we built a web app that allows anybody to design a school. And when I say when I say anybody, we really mean anybody. So this is, I was demonstrating this app with some children, which is absolutely terrifying to take your software product to an audience you have absolutely no idea what they're going to say, and it was a bit nerve-wracking. But the idea of this app was to allow anybody to design, not just architects, but a teacher, a parent, or a child to be part of a design process to do early stage planning of what their school could be. So you simply choose your location, choose your school type, and start placing pre-configured clusters of classrooms, of support spaces, all the things you need to go into a primary school. The idea was that this would be something a little bit like Minecraft. We were a bit worried we were going to make the world's most boring computer game, but it's always a risk, right? But actually, the kids were pretty happy with this, and rather amusingly at the end of it, and the kind of feedback we got was they actually said, "This is great, this is better than Minecraft, can we have one for housing?" So this is an open source web app for housing that we've also done, which Paul mentioned. So this is something we did with CAST and with the Mayor of London's office to encourage the adoption of precision manufactured housing. That's a term from the GLA. So they approached CAST and ourselves around a year and a half ago, looking for a way to turbocharge the adoption of precision manufactured housing across the sector. And it's pretty open as to what solution we could choose for that. It could be a report, it could have been a series of documents, it could have been anything really. But we felt another report or another document would be a bit tedious and no one would ever read it. So we wanted to create something more ambitious than that. So we wanted to build some technology for others to use. And again, there's an absolutely terrifying process. Making a piece of software to design houses that not only architects but anybody else could use, that's also terrifying, the kind of feedback you might get. So this is a very interesting experience. The idea of this tool is that, that you can choose your site, you can build your building, and you can find out how easy or not easy it would be to deliver your design with a range of precision manufacturing housing techniques. One of the things really interesting about this project actually is the range of stakeholders involved. And the contribution they were able to make. So the app is based on a small piece of data analytics using stakeholder development data that they provided collectively, that we could analyze room sizes, apartment sizes, dimensionality within recent developments. There's a big step, right, to share your development data. That's not that obvious or easy to do, but it's a super positive part of the project. We launched this about 6 weeks ago, and again, it's very similar to the similar principle to the schools app. You choose your site, demolish your building, if only it was that easy, and start choosing your housing types and start generating a design. You can come up with a design in this software for a pretty plausible housing development early stage in about 10 minutes. And with practice, you can really get that down. You're getting feedback on metrics around its efficiency, net to gross, your performance against your brief setting, your apartment areas. You have a library of apartments you can pick from, and you can modify. And then you get this feedback as to how plausible it is to deliver your housing scheme with any of the precision manufactured systems. So whether that's volumetric modular, CLT, hot rolled steel, cold rolled steel, whatever it happens to be. So you can keep your options open, or you can target into one of them. And this allows not an architect to design that building in total. It allows anybody to start and to set a brief. So if you're a developer, you're able to access this, play around with your metrics, and pass that on to the architect for them to work up. But this is about, as I say, it's not about just doing it faster. This is quick, clearly, but it's smarter. You're getting design intelligence embedded into it, and design intelligence that is then passed on to a whole different range of users and stakeholders. And then the last example is so it's a bit spooky. It's spooky because it's infrastructure, it's transport infrastructure rather than property per se, but obviously transport infrastructure sits in between all of our property. And this project, for me, represents a really clear example of how the adoption of technology and technological approaches, digital approaches, allows our business and people in our team to do things that we might not normally be expected to do or actually even allowed to do. So we've been developing something called the Rapid Engineering Model for the last 2 years with Highways England to automate the design of smart motorway schemes. So for those of you who don't know, the Smart Motorways program is the expansion of the UK's motorway network by converting the hard shoulder into an active running lane. Well, at least that's part of it. And as I mentioned at the beginning, we're mostly architects in my team. We've never done any road design at all, ever. Like ever. If you want to do roads, you normally have to, you have to have done it for 25 years. It's a bit of a mystery to me. If you can only ever have done it for 20 years, how did you ever start? But because we were able to get into it through a technology-led approach, a digital-led approach, we're bringing something completely different, answering the question in a completely different way. So this is kind of visuals from the sorts of apps we've built. So this is analytics of it. That's a real road, actually, showing our data analytics and visualization that overlaid on top. I won't go through all the details because it's a bit too esoteric, perhaps. But this is an example of how us picking up an infrastructure problem that we wouldn't normally be able or asked to tackle, but taking it with a tech-led approach allowed us to be super successful and provide a completely different kind of value and insight. So in this case, this is automated design analytics for a stretch of road, which normally the client would have to wait a year, 9 months or a year to receive. In this case, we're able to generate the data and present it into this web app within 3 days. So there's a huge time saving here. They're able to do many, many, many more iterations. They're able to understand much, much more about any likely issues they might find. And they're able to have much more certainty around project delivery. And obviously, there's different scales to this. This is a geospatial version of what you just saw. This is a virtual reality app that allows that client to access the network-wide data at a national scale, understanding road performance, and understanding construction schemes within a wider context, within an infrastructure network, as well as being able to drill in then to those specific schemes. And this is very different to how it was normally done. No one normally designs roads like this, but a bunch of weird architects who decided to take a tech-led approach to design and automation. We were able to kind of implement some of these things for them. And I think that's the lesson for me in all of this. In the last 18 months, we've been able to build apps and technologies that actually we never even planned to make. It wasn't our intention was not to get to this level this quickly. Our intention was to see where this would take us. We knew we needed to do something different. We knew the role of the architect or the engineer is going to change, and we wanted to be the ones that instigated that change and that led that change rather than being, let's say, disrupted from the outside. Somewhat disruption from the inside is at least a little bit something you can maybe control. And it's provided us as a business with a huge different range of opportunities in sectors that we can go into and think capabilities that we have and just things that we can do and services we can offer and value that we can provide. It's really kind of been a game changer for us and something that in a actually reasonably short amount of time, in that sort of year and a half, has been, like a super success for us, and it's a big indicator of the trajectory we think the industry needs to take, and also as well as ourselves as a business. So that's all. I'll stop there.